What's up, kids? We're going to talk about trig today. Here is your bell ringer. Here's your Y. And you're just trig. So this is just talking about labeling. Sine, cosine, and tangent. And what we're going to use trig for is finding missing side lengths and angle measures of triangles, which will be useful when you go into pre-calc, calculus, and all that good stuff. And it's also useful, probably one of the most applicable things we're going to do for real life, because you can find angles of elevation and depression without even having to measure it. So it's basically what surveyors do when they're out on the road. But before we can start using it, we have to be able to talk about it. So you'll see that we have sine, cosine, and tangent. And these represent ratios in a triangle. So we're talking about angle A. And sine is equal to opposite over hypotenuse. Sine is equal to opposite over hypotenuse. So the opposite side is opposite the angle. The hypotenuse is just hypotenuse. Cosine is the adjacent side over the hypotenuse. So the adjacent side over the hypotenuse. And tangent is equal to the opposite side over the adjacent side. And that's how we're going to label trig functions. Here, we're going to skip over example 1 and that try it. We're going to go straight to example 2, the meat and potatoes. What are the sine, cosine, and tangent ratios for h? So we're using h. I invite you to do this every time. Label the angle you're using, draw an arrow, and label the adjacent side. Just keep it straight. So sine is equal to opposite over hypotenuse. So 12 over 15. Cosine, we do have to put an h in there. Sine of h. Cosine of h is equal to adjacent over hypotenuse, and tangent h is equal to opposite over adjacent. 9. And that's all you gotta do. You just gotta label those sides, label those ratios. Try it. Example 2, what are the sine, cosine, and tangent ratios of f? So label your new angle, draw opposite, draw adjacent. Sine of f. Sine of f is equal to 9 over 15. Cosine of f is equal to 12 over 15. And tangent f is equal to 9 over 12. So what is the difference between what we just did and that? The first one is 12 over 15. This one is 9 over 15. So what I want you to recognize is that different angles will give you different trig ratios. The angle that makes the ratio. What is the sine? Sine, cosine, tangent ratios for 30, 45, and 60 degree angles. So let's draw our special right triangles. 45, 90, where this is 1, 1, square root of 2, and 30, 60, 90. 30, 60, 90, where this was 1, this was the square root of 3, and this was 2. So what are the sine, cosine, and tangent ratios for 30, 45, and 60? Okay. I'm trying to think of the best way to do this. Let's do 30. And the sine, I don't want to draw on that. It's pretty hard to do. Just got to visualize. Sine of 30 is equal to 1 over 2. Cosine of 30 is equal to square root of 3 over 2. And tangent 30 is equal to 1 over the square root of 3, which is also known as the square root of 3, because you can't have a square root on the bottom. So then what you would do there is you have 1 over the square root of 3. You'd have to multiply the top and the bottom by the square root of 3 to get that radical out of the bottom. And that would leave you with the square root of 3 over 3. 45 degrees. A different color for you. Sine of 45 is equal to opposite over hypotenuse. So same thing, square root of 2 over 2. Cosine 45 is equal to square root of 2 over 2. And tangent 45 is equal to 1. Opposite over adjacent. Last but not least, 60 degrees. Sine of 60 is equal to square root of 3 over 2. Cosine of 60 is equal to 1 over 2. And tangent of 60 is equal to square root of 3. So now all these ratios are going to be present in the unit circle. Unit circle. From the time I was in geometry, all the way up through calculus in high school, or in college, and even beyond that into diffie-q and linear algebra and discrete algebra and all those good things, I would write the unit circle on the back of my notebook. And I would always have it available because it's used in all the classes that you'll be using going forward in your education, especially if you go into a math field. Fun fact. Use the trig ratios to find the value of x. Find the value of x. So we can either do so we have an adjacent side and a hypotenuse. So that is cosine. Cosine of 45 is equal to square root of 2 over 2. And it's also equal here to 6 over x. So we have to say, how do we get square root of 2 over 2 equal to 6 over x? Cross multiply, square root of 2, x is equal to 12. X is equal to 12 over the square root of 2. Can't have a radical on the bottom, so multiply the top and the bottom by square root of 2. You'd have 12 square root of 2 over 2, which is equal to 6 square root 2. We could have just done the shortcut. Silly. Let's keep with the vein though. Just keep doing it with trig functions. We have an adjacent hypotenuse. Let's use cosine again. Cosine of 30. Cosine of 30 is equal to square root of 3 over 2. And it's also equal here to x over 12. So square root of 3 over 2 is equal to x over 12. 12 square root of 3 is equal to 2x. And 12 divided by the square root of 12 times square root of 3 divided by 2 is equal to x. And 6 square root of 3 is equal to x. There you go. So I'm going to throw a challenge out to you. Memorize these ratios and show me when I come back. I'll be very impressed. Here's a try it. What is the value of y? So let's not waste our time this time. We know the shortcut. This is 9 square root of 3 over 3, also known as 3 square root of 3, which means that this is 6 square root of 3, using that 30, 60, 90 triangle shortcut. 45, 45, so we know that this is 24, this is 24 square root of 2 over 2, which is also known as 12 square root of 2. You can evaluate that in your calculator as well. Whichever way floats your boat. Here is your list. All right. Hope you're having a wonderful week. See you.